So remember that the definition of the field for gravity is that G is F over m, right? Now we know that the force between two masses is G m1 m2 over r squared, and so therefore if we divide this by a mass, right, then we get that the G at some distance from a point mass is Gm over r squared, right? And we can do the same thing for electric field, right? Electric field is defined as the force per unit charge, right? The force is K Q Q over r squared, and if we divide that by a Q, right, then we get that the electric field at some distance from a charge, right, is K Q over r squared. Now, this formula is not in the data packet. You have to, I guess, infer it. I don't know. I don't know why it's not in there. Okay, and then we can do the same thing that we did with vector force, right? R squared, right, is going to be this. Well, let's see. R is going to be the square root of the x distance squared plus the y distance squared. That's just the distance formula, right? So r squared is going to be this thing squared, and so basically r squared is just, this is the Pythagorean theorem, right? Thank you, Pythagoras. Okay, so these, the formula for the electric field, right? This is what we're going to use, K Q over x squared plus y squared, okay? And then, if you're flattening the expression, definitely parentheses, right? So let's just take a look at this. So what is the magnitude of the field at the x? That's 1.35 microcoulombs. That's a positive charge, right? So notice that the electric fields are away from positive charges toward negative charges, right? Because it's what would positive charge do, right? Okay. But we're just talking about the magnitude of this electric field here. And that's going to be E is K Q over R squared. Again, not in the data packet, right? So that's going to be, in this case, 8.99 E9. And then it's times 1.35 E minus 6. And then we're going to divide by 2.8 squared plus 4.62 squared, right? So 8.99 E minus 6 divided by left parenthesis, because I didn't use the fraction, 2.8 squared plus 4.62 squared. And this ends up being 415.8557 newtons per coulomb. And it's going to be away from this charge, so it's going to be in this direction like that, right? So what angle does the field make with the x-axis? Well, it's going to be the same angle as this, right? If we drew a line there, this angle and this angle are, I think we decided what kind of angle that was, but I forgot. All right, so, but we know they're congruent, right? Okay, so I'm just going to find this angle here, and that angle is going to be the inverse tangent of the opposite side, which is 2.80, over the adjacent side, which is 4.62. So 2.8 divided by 4.62, assuming that we are in degrees, right? Not that I ever made that mistake in my life. Divided by 4.62. This is 31.218. Okay, now this is to the left and up. And this is above. And I always sort of write this down. Somehow this makes me not make mistakes. Above the x-axis, okay? Left and up, okay? So that means that our x component is going to be negative. This guy's going to be negative. This guy's going to be positive, okay? We've got these little components here, doodly-doot and doodly-doot, okay? So our x component is going to be, and I'm just throwing a minus sign on there because this guy is to the left. Okay, negative 415.85 0.8557 times cos. And the only place that minus sign comes from is the fact that I know this has to go left. And it's cosine of 31.218. And really, I'm just using the up arrow on my calculator. So I'm going to go opposite of, go up and grab the 415 number, times cos. I'm even closing the parentheses here. I hope you guys are appreciating that. Okay. Negative 355.6389 newtons per coulomb in the x direction. That's ridiculous sig figs. Really, I would use a spreadsheet is what I do. And then my y component is going to be positive 415.8, right? Times sine of, and I always find the angle with the x-axis, by the way, when I'm doing these. Because I know that if I, vary from that, I'm such a spaz that I'm going to make one little mistake and then I'll be in trouble. I got to close the parentheses. Got to be hyper about that. Okay, so I'm going to do the same thing. I'm going to grab that value on my calculator times sine of, I'm going to grab the angle, and this is positive 215.5387 newtons per coulomb in the y direction. So the vector is actually negative 355.63 ... newtons per coulomb in the x direction plus 215.53 ... newtons per coulomb in the y direction. There we go. So that's all well and cool. One little mistake in here, and you're going to crash your spaceship. Okay, so just double check your left and your up, and that you're not, that you're finding the correct angle. We know that's an adorable angle, right? Because this side's smaller than this side. I mean, just do slow, careful work there, which I'm not very good at, right? So as you do these, right, we're finding the electric field at P. Okay, I'll always give you one that's like a 45-degree angle. Okay. The electric field due to A, remember it's toward negative charge, away from positive charge. Okay? For masses, it's really simple, right? It's always toward the mass. Okay? Because remember, gravity, just like me, is always attractive. Okay? Did you laugh? Did somebody laugh? Did anybody laugh? Or did you just sort of smile and be like, oh, okay. Anyway, so if you look at this guy here, the electric field due to A is going to be toward A. That's the electric field of A. Don't make this mistake, right? Okay? But the electric field due to B is going to be away from B. And then you can figure out these angles, right? This is going to be 45 degrees. This guy's going to have a positive x component, negative y. This guy's going to have positive x and positive y. And then if we look at this guy, the electric field due to, electric gravitational field due to A is toward A. Okay. The gravitational field toward B is toward B. This is just simple. It's just toward those, two-word those, okay? As opposed to fromward, right? Okay? Get caught up with where the class is supposed to be. Look at the calendar, look at the stuff you're supposed to do, and make sure you're staying caught up with the class, okay? I'm going to stop talking. All right.